after making the basic dissolve shader, we are going to make to do one step further with the same concept, adding just two new things to make a cool effect. And this is the distance-based mask dissolve. Okay. We are going to keep the alpha clip material ideas. That's mandatory in order to work. We are going to keep the noise mask. We are going to keep the emissive mask and the color for the border, but the dissolve amount parameter is going to be removed, and instead of that, we are going to have a new mask that is controlled by distance. We are going to need two new variables to control this mask and a small C# script. It's going to be super small. You can even copy paste it from the one that I'm doing. It's super simple. So here in the project, I'm not going to show the final result, but I'm going to keep working in the same capsule that I had, okay? For that, I'm going to duplicate my basic dissolve shader. I'm going to rename it, and I'm going to call it my distance dissolve shader. I'm just doing it because I'm going to reuse a lot of stuff from the shader. And to my dissolve material, my basic dissolve, we can just duplicate it or reassign, but yeah, anyway. My distance dissolve. Here, assign the shader. My distance is dissolved. It looks the same because it's copy pasted. Let's open it. First, we said that the dissolve amount value is not going to be here anymore, so we just get rid of it. Now, instead of having this here, we are going to add something more to the mask that I'm going to develop here. Okay, but I need to create a new variable. Oh, by the way, I haven't deleted this variable, so right click delete. I'm going to create a new one. It's going to be a vector3 variable. It's called position. Okay, so this position is going to be controlled by the C# script, right? I'm going to change this sphere. Okay, this looks okayish. Okay, yeah. It's going to be controlled by a C# script. I can put any value here, but I'm going to override it on at runtime to make the nice position effect. So what do we need? We have the position. This position represents the tracked object, and we are going to have the position of the pixel from the engine itself. There is another called position. Here you will get the position of the mm, pixel. You can change it to object view, world, or tangent, the different spaces, but we are going to use the world space. Later, we are going to calculate the distance, right? It's called distance between these two positions. This distance right now position is at 0, 0, 0. It means, imagine that, yeah, I think that if we draw this into the emissive emission, yeah, here. And we're going to put this as a quad here. This is the quad. 0, 0, 0 is the center of the screen right now. This means that at 0, 0, 0, your distance is in this point, this black area, your distance to 0, 0, 0 to the position variable is lower than here. White means a higher value than black. So now I want to change the I want to change a bit the position so you can see how this thing changes. For example, I'm moving, yeah, I cannot move this too far away, but position right now it's at x equals 0.3. You can see that the black dot is moving. X 0.3 is more or less here in this kind of world, right? That's why you see this black dot here. If you move it up, it goes up, right? This is a demonstration on how this shader is going to work. But this is just the position mask. We also have to control it by the distance. So we have to create another variable called distance. It's going to be a vector1 variable. So this distance by default, just let's use 1. So we're just going to divide this mask, divide by the distance. With this, I can control how far. So the mask starts to react when the object, the tracked object, is in that distance. For example, with this value, I can change, for example, if I just put 3, it the whole picture gets, let's put it here. The whole picture gets darker because that means that the object is further. Yep. So this is the distance, is to help regulate how close the dissolve effect is going to start. Later, since that's the thing, this value here is something, it's an image, it's a mask between 0 and 1 that is going to work as the dissolve value that we had before. So the dissolve value that we have, this dissolve amount that we had before was between 0 and 1. 0 was mean don't dissolve the object, 1 mean dissolve the object. Right now, if we look at this, the black dot is 0 and the black dot is showing where is the position. So 0 means don't dissolve. So this mask right now is don't dissolve when the object is close. So we have to invert it. But before invert it, we have to clamp. Those are distance values. They don't need to be between 0 and 1. So by clamping it, we will be sure that it's there. Then we have to invert the mask. Now that we know that the mask is between 0 and 1, inverting a mask is just an operation called 1 minus. And here in this image, the white value is at the center and the black value is at the border. Okay, so instead of just putting it again into the emissive, I'm going just to add it to the noise texture. And there we have it. Let's just have a sphere. Now we have a sphere and we can play a bit with the distance value. For example, I'm going to, instead of having here distance, I'm going to have a slider that is big enough. No, it doesn't let me work. Okay, just default, just a value. If we have 1 and the position of the object, as you can see here, I'm moving the object. 1 position is just 1, is here, let's say. Okay, so when I move the object to 0, it starts dissolving the object. If I put the distance a bit more, 2, I think 2 is cool. I get this nice effect. It's already working. You know, this space is kind of weird to visualize it because this sphere is not 0, 0, 0. But you can see that it's kind of already working. But in this shader, we are not going to move manually the dissolve amount and so on. So let's call this group everything here, group selection, and call it distance mask. And as you can see, oh, is the dissolve mask is actually a distance-based dissolve mask. It's the same, but instead adding a dissolve amount, it's just small distance. And here we have the emission. Let's plug it again. So we get a nice border again. Probably it's going to be broken like that last time because the default value, we are not going to see it, but let's see my distance dissolve. Okay, the border value is okay. Yeah, but we cannot control the dissolve. So how do we control the dissolve? For that, we need a script. So the script, I already have it here. It's called, no, not really here, but yeah, I'm going to create it from scratch. So right click, create C# script. Let's call it, I don't know, distance dissolve target. Why target? Because this script is an example of how a game mechanic could work, and it's going to track an object. So what do we need to do with this script? It's an empty mode of behavior, and we need to track a game object, get the position and the position of that game object, and use it as a value of the material and change that value every frame. So it gets updated every frame. This is a small example of how to do it, and it could be improved a lot depending on the mechanic. So first thing first, if you don't know programming, don't worry. I'm going to do it super fast. Just copy it and just get a programmer to do it. So I'm going to create a public variable. It's going to be the object that I'm tracking. It's a transform, so you can get the position. And in order to do it properly, this is programming stuff. When you change a material, if you don't want to change the shared material, which is all it's the global material for all the elements, you only want to change one object, you have to create a material instance and then delete that reference. Otherwise, you are creating garbage on the memory, a memory leak. So yeah, let's get a material reference variable. Let's get a renderer class component renderer. I'm getting this component here because I don't like to do get components every frame. So in the awake, we're going to run and pre-cache our variables. We get the renderer. It's going to be the same. It's already cached. You don't have to do get component every frame. Let's get the material instance for this renderer. Okay, right. But this is the idea. We just cache everything, but this is on runtime. I also want this to run on the editor. So there is a tag here called execute in edit mode, but now we have to be a bit more careful because the awake doesn't get called always on the editor. For runtime, this is perfect, it's nice, you will keep your references. But we need getters, so I'm going to create properties. Okay, so this property, if the variable renderer equals null, then I'm going just to repeat this and then return. If I don't have it cached, do it. And the same with the material. Material ref. And it's exactly the same idea. If my material ref equals null, material ref, and now instead of using m underscore renderer, I'm going to use the property renderer, because this property will always return the value, even on editor. And if it is already cached, it's already cached. Okay, so those are the two properties that we need, two getters, and then we need private update, no, private void update, and if the object to track is different from null, let's track that position. So it's just material ref, and then we have a lot of methods to set variables into the material. We have to set a vector, set vector. It was called underscore position, and now the value. So we need a value, and that value is the object to track dot position. So by doing this, we are already tracking the position. If the object to track is not assigned on the editor, it doesn't work. If it is assigned on the editor, here, this is the problem. Okay. Here I have to use material ref, because if I use material ref, it will always pre-cache the renderer and pre-cache the material. So I don't have to use a get component every time. And in order to be clean, private void on destroy. You could also do it on disable. It depends. On destroy, destroy. Well, first and render. I like to do this because I'm maniac and super order. Then destroy material ref. Sorry. If material ref is different from null, destroy material ref equals null. With this, I'm telling the engine, hey, I've stopped using this material that I have created with this call in memory. Just get rid of it. Okay, the garbage collector will come, okay, but I don't have a memory leak. And you could manage when to do this, but yeah, you create it on the awake. Let's say you destroy when the end gain object destroys. So this is a super small script, and is going to control a track object. So I'm going to create a new object. Right click, okay, it's compiling. New object, create a 3D object. It's going to be a cube, small cube. I will want a small cube. Uh, and I think I have a material somewhere in the project, so it's called track object. Yay! It's this glowing thingy that I have. It's just an emissive material. Okay, and we are going to add, let's call it tracked object. We are going to add a script called distance. Oh no, not in here, sorry. In the capsule, distance dissolve target. So yeah, it will get you an error like, hey, you are calling render.material during edit mode. This will leak materials into the scene. Okay, but if you get care of the materials, you're fine. So here, this component, you tell him, hey, this is the object that I want to track, and it just runs on edit mode. Now we have to work a bit with the material. This capsule has my basic dissolve shader. Yeah. So let's change this to my distance dissolve. This is the distance dissolve material. Let's see. Capsule. Is everything alright? Distance is 2. HDR. Let's debug. Ta-da. Here, let's see if it is debug log. object to track dot position. Let's see if we have a position here. If it is working as intended, it should compile and we should, yeah, we're getting the position. So the script is updating the position. So maybe my distance dissolve shader noise albedo emissafe border position doesn't get updated here. Why? Let's see. Oh yeah, I know why. I changed the material in runtime. Okay, just put it again. Just cleaning the variables. It already created a copy of the material and it was using a different one. Now we have it. So yeah. Now if the object gets closer to a distance of 2 as it is assigned here, the mask will react. If I choose 1, the object has to be closer. So it starts doing the dissolve. This is too close, let's say 3. 3 is fine. It's like, yay, dissolve, yay, it goes away. It works in all directions because it's world space from the top, below. And if you really want to see how the distance mask work, you could just go here to the shader, get rid of all the clip thing, and just draw the distance mask on the emission. It's okay. Save the asset. And you will see how it's black and how it reacts. So this mask combined with the noise mask creates this effect. Also with the alpha clip and so on. And then you get, and I want to change the values. Maybe I can just get the tracked object color. Ah, it's already swatched. Okay, perfect. And now it matches. Yay, too glowy. Let's reduce intensity. Yeah, perfect. So this is the distance based dissolve shader.